Hello friends. Manufacturing technologies can be broadly classified into three categories: additive, subtractive, and formative. Each method has its own way of shaping raw materials into final products. Understanding the differences helps us select the right process for a specific application. Myself, Dr. Debal Pramanik, Assistant Professor of Swami Vivekananda Institute of Science and Technology. Today, our fourth lecture on comparison among additive manufacturing, subtractive manufacturing, and formative manufacturing. First, additive manufacturing. That the methodology is addition of layer, that means layer by layer manufacturing. Subtractive, that means removal of material. Formative means shaping of material. These are the basic comparison between the additive manufacturing, subtractive manufacturing, and formative manufacturing. Then volume, must customized or customized we can create in additive manufacturing. Medium volume is created in subtractive manufacturing. High volume can create in formative manufacturing. Lead time less, subtractive high, formative medium. Raw material used in additive manufacturing that may be shapeless material in the form of powder, wire, or etc. In subtractive, the raw material can be used bulk material. Formative, molten material or bulk material may be used. Buy to fly ratio is low in additive manufacturing. In subtractive, that is high. Formative, that is medium. Surface finish. In additive manufacturing, we can achieve low to medium. Subtractive, medium to high. And formative, that is medium. Dimension accuracy we can achieve in additive manufacturing low to medium. Subtractive dimensional accuracy is very high, and formative it is medium. Material we can use in additive manufacturing low limitations. We can use plastic, metals, ceramics. Subtractive limited by material hardness. Formative metals and plastics. Size of components. In additive manufacturing, limited to machine size in most cases. Subtractive, large components can be machined. Formative, large components are possible. Complex geometry may be possible in additive manufacturing. Subtractive is very limited. Formative, medium. Logistic freedom, that we can move the additive manufacturing machine easily, that is yes. Subtractive, no. Formative, no. Speed, machining speed can be relatively slow in additive manufacturing. Subtractive, fast. Formative is fast. Green technology, additive manufacturing reduced material wastage, so that this is green technology. Subtractive, high material wastage. Formative, reduce material wastage. So these are the basic comparison among the additive, subtractive and formative manufacturing. So next, that are the classification of additive manufacturing. So these are the basic classification, that fat photopolymerization, binder jetting, material jetting, sheet lamination, material extrusion, powder bed fusion, and directed energy deposition. First, wet photopolymerization. Wet photopolymerization or stereolithography is defined as an additive manufacturing process in which liquid photopolymer in a vat is selectively cured by light activated polymerization. Binder jetting is defined as an additive manufacturing process in which a liquid bonding agent is selectively deposited to join powder materials. Material jetting is defined as an additive manufacturing process in which droplets of build material are selectively deposited. Sheet lamination is defined as an additive manufacturing process in which sheets of material are bonded to form an object. Material extrusion is defined as an additive manufacturing process in which material is selectively dispensed through a nozzle or orifice. Powder bed fusion is defined as an additive manufacturing process in which thermal energy selectively fuses regions of a powder bed. Directed energy deposition is defined as an additive manufacturing process in which focused thermal energy is used to fuse material by melting as they are being deposited. So these are the basic classification of additive manufacturing technique. Thank you.